Monitoring gases like CO2 and O2 is critical for safety, indoor air quality, and industrial processes. So let's understand how gas sensors and gas transmitters work. Hello everyone, this is Raj from TechArt, your process automation strategist. In the previous module, we have learned about moisture and oil condition monitoring, including moisture sensors and moisture in oil monitoring system. Now, we will move to another important area of industrial measurement, and that is gas measurement systems. Many industrial processes involve gases such as carbon dioxide, oxygen, compressed air, and process gases. Monitoring these gases is very important for safety, process efficiency, and environmental control. So, today we will understand gas sensors and gas transmitter and where they are used in industrial applications. First, let's understand gas measurement with a simple example. Imagine a meeting room with many people inside. If the room does not have proper ventilation, the CO2 level in the air starts increasing. When CO2 becomes too high, people may feel sleepy, uncomfortable, and low concentration will be there. So many modern buildings install CO2 sensors to monitor indoor air quality. When CO2 levels increases, the HVAC system increases fresh air ventilation. This is a simple example of gas monitoring system. Now let's understand why gas monitoring is very important. Gas monitoring is important in many industries. Let us look at few examples. Offices, hospitals, classrooms, and labs monitor CO2 levels to ensure proper air quality. If CO2 concentration becomes too high, ventilation systems automatically bring fresh air into the room. This helps to maintain a healthy environment. In industries like food production, brewing, and biotechnology, fermentation processes produce CO2 gas. Monitoring CO2 concentration helps engineers control fermentation conditions. This ensures consistent product quality. Now, many industrial systems use burners and furnaces. These systems require the correct amount of oxygen for proper combustion. If oxygen levels are too low or too high, combustion efficiency decreases. And oxygen sensors help to monitor O2 concentration in combustion system. This improves energy efficiency and safety. Let us first understand CO2 sensors. CO2 sensors measure the concentration of carbon dioxide in air. The most common technology used in CO2 sensor is called NDIR. NDIR stands for non-dispersive infrared sensing. These sensors detect CO2 by measuring how carbon dioxide absorbs infrared light. CO2 concentration is usually measured in ppm, which means parts per million. Typically, ranges includes 0 to 2000 ppm, 0 to 5000 ppm, and 0 to 10,000 ppm. So, CO2 sensors are widely used in indoor air quality monitoring, HVAC systems, greenhouse, and fermentation monitoring. Another important gas measurement is oxygen measurement. Oxygen sensors measure the percentage of oxygen present in air or gas mixtures. Normal atmospheric air contains about 21% oxygen. Oxygen sensors are used in applications such as combustion monitoring, industrial safety systems, medical oxygen monitoring, and process control. Different technologies may be used for oxygen sensing, such as electromechanical sensors or zirconia sensors for high temperature applications. Gas sensors usually generate small electrical signals. These signals must be converted into standard industrial output. This is done using gas transmitters. Gas transmitters then convert the sensor signal into outputs such as 4 to 20 mA analog signal, 0 to 10 volt output, or Modbus digital communication signals. These signals can be connected to PLC system, building management system, or SCADA monitoring system. Now, gas transmitter allows continuous monitoring of gas concentration in real time. Correct placement of gas sensor is very important. Gas sensor must be installed where the gas concentration can be accurately detected. For example, CO2 sensors for indoor air quality are usually installed on walls at breathing heights. Gas sensor in industrial environments may be installed near gas sources or exhaust areas. Incorrect sensor placement may lead to inaccurate measurement, so proper installation planning is very important. Now, let us take practical example. A customer says, I want to monitor CO2 levels inside my office building. As an application engineer, you should ask, what is the measurement range required? Is the sensor for indoor air quality monitoring? Does the system require 420 mA output or Modbus communication? Based on these requirements, you can recommend a suitable CO2 transmitter with wall-mounted installation. This is how application-based gas sensor selection works. In this module, we have learned what gas measurement systems are, types of gas sensors such as CO2 sensors, O2 sensors, and we also discussed gas transmitters and applications such as indoor air quality monitoring, fermentation processes, and combustion monitoring. Gas monitoring plays a very important role in industrial safety, environmental monitoring, and process control. Understanding gas measurement technologies help application engineers recommend a reliable gas monitoring solutions to the customer. In the next module, we will move to instrumentation system integration, where we will learn how sensors, transmitters, controllers, and data workers work together in real industrial systems. Thank you so much for watching. See you all in my next video.